Hi all, I am K. Surya, working as Assistant Professor in the Department of PCE at SNS College of Technology. In this video, let us see about AC and DC characteristics of operational amplifier. First, we'll see why we need to have DC characteristics. In an ideal op amp, it draws no current from the source and its response is also independent of the temperature. So for a real op amp, it does not work in this way. So current is taken from the source into the op amp inputs. Also, the inputs respond differently to current and voltage due to mismatch in the transistors. So a real op amp also shifts its operation with the temperature. So DC characteristics are input bias current, input offset current, input offset voltage, and thermal drift. First, we'll see about input bias current. So the average value of the two currents flowing into the op amp input terminals is called as the input bias current, which is given by IB. The two input currents are identical due to mismatch in the transistors. Let IB1 be the current flowing into the non-inverting terminal and IB2 be the current flowing into the other terminal. Then the input bias current is given by IB is equal to IB1 plus IB2 by 2. Next one is the input offset current. So the input stage of the op amp is a dual input differential amplifier. Hence the input currents of the op amp are the base currents of the transistors used in the input stage. Due to the transistor which mismatch, these currents will differ. So the algebraic difference between the currents flowing into the two input terminals of the op amp is called the input offset current and it is denoted as IIOS and it is given by IIOS is equal to modulus of IB1 minus IB2. Next one is the input offset voltage, which is the differential voltage that is required to apply between the two terminals of the op amp, such that the output of the op amp will become zero when no input is applied to the op amp. Output offset voltage is the multiplication of DC gain and the input offset voltage. Next one is thermal drift. It is the changes in the normal operational behavior of a device due to changes in the ambient temperature. Drift caused by internal heating of the equipment during normal operation or by changes in the external ambient temperature. There are very few circuit techniques that can be used to minimize the effect of drift. Careful printed circuit board layout must be equal to be used to keep op amps away from the source of heat. Forced air cooling may be used to stabilize the ambient temperature. Next one is we'll go for AC characteristics. So the purpose of this AC characteristics is that in a circuit is to amplify a small AC input signal such as an audio or a radio frequency signal. A small AC voltage is applied to the input through a coupling capacitor. Hence, such a circuit is useful only as an AC amplifier. To amplify the DC signal, separate operational amplifier circuits are used. So for small sinusoidal applications, the AC characteristics are frequency response and slew rate. So frequency response, you know that for an ideal amplifier, the bandwidth is infinite. So the open loop gain is 90 dB with the DC signal and this gain should remain the same through audio and radio frequencies. But practically op-amp gain decreases at high frequency. So this is due to the capacitive component that is present in the equivalent circuit of the op-amp. Next one is slew rate. The slew rate is defined as the maximum rate of change of output voltage caused by a step input voltage. This is specified by voltage per microseconds. For example, 1 volt per microsecond, slew rate denotes the output rises or falls by 1 volts in 1 microseconds. The rate at which the voltage across the capacitor dVc by dVt is given by dVc by dt is equal to I by C. Slew rate SR into dVc by dt max is equal to I max by C. In IC741, Imax is equal to 15 microamps and C is equal to 30 picofarad. Slew rate will be 0.5 volts divided, 0.5 volts per microsecond. Hope you understood the AC and DC characteristics of op-amp. Let us take up some assessment questions. What is the need to generate corrective control voltage? The answer is to maintain the lock. Next one is which factor determines the output voltage of an op-amp? The answer is both positive and negative saturation voltage. So the saturation voltage depends on the supply voltage which we are giving to the op-amp. Next one is ideal op-amp has infinite voltage gain because the answer is to obtain finite output voltage. Thank you for watching this video.